In our previous video, we established that, at least in standard difficulty, Hide and Go Beak is rigged. However, the data we collected led us to more questions. Does this differ between difficulties? Does it differ between Miis? What is the actual distribution for each placement? Does the number of human-controlled players matter? Well, we can only answer one part of one of those questions today, and that is going to be, is Hide and Go Beak rigged on beginner difficulty? Now, before we begin, I do just want to say thank you all for the support on the first episode of this series. I really appreciate it. It blew me away with all the support. Y'all clearly seem to enjoy it, and I hope you enjoy this episode as well. Don't forget to like and subscribe, and let's get into it. So, to answer this question, we're going to use a very similar process to what we used for standard difficulty. I go into more detail about my assumptions and why I'm making them in the first video in this series, so make sure to go check that one out after you're done here. In short, however, we're assuming that, number one, the number of human players doesn't affect the game's behavior, i.e. whether only one human player is human-controlled versus 2, 3, or 4 has no effect on the game's behavior. Number two, each game is an independent trial. That is, the outcome of the previous game has no effect on the outcome of the next. And finally, and most critically, there is no difference in the game's behavior playing through mini-game mode versus playing through a main game. Basically, what we're assuming is that the behavior the game displays through selection in highway rollers is the same as when it's selected in mini-games. Similarly, I'll be using an identical procedure and analysis to the previous video, except we're going to be testing on beginner difficulty instead of standard. So to refresh your memory, let's run through it again. So step 1. Set the CPUs to standard difficulty and keep them the same throughout testing. Step 2. Play the minigame in the minigame selection. Step 3. Select the furthest left bush to hide behind. Shockingly, this was always the same kind of bush, so that was interesting and eliminated a variable I was very worried about. Step 4. Record results, including whether the leftover bush got knocked over by the ostrich. Step 5. Repeat steps 3 and 4 until 100 trials have been completed. In short, our procedure will allow us to get rid of any extraneous variables that could cause a systematic error. Basically, that's an error with the procedure that is going to invalidate our results. And our analysis is going to let us determine the probability that our data follows our theoretical distribution. In our case, if Hide and Go Beak was truly random, we would expect to see each placement occur 25% of the time, theoretically. As such, we'll be reusing our two hypotheses from the first video and the significance value of 0.05. If our analysis yields a value less than our significance level, then we have sufficient evidence that Hide and Go Beak on beginner difficulty isn't truly random. And if the value is greater than or equal to our value, then we don't have sufficient evidence to say Hide and Go Beak truly isn't random. With all of that in mind, let's get into the data. And I just want to say that this episode has left me more confused than anything else. What you're seeing on your screen now is the graph and table of the first trial I did with grouse. The first thing I noticed when I was making this was the stark difference in my Miis results between this video and our previous video, which I was very surprised by. I was actually expecting it to be even more blatant, with first and second place getting closer to 60% of the total results, if not more. So this I did not see coming. In the meantime, all other results are in fact interesting. Pitt got last place around a third of the time, while Adrian, Donna, and myself all got either first or second a majority of the time. Intuitively, Pitt is the case that is most interesting, and that's reflected in our analysis, where his p-value, and how I got the work for that is on your screen now, that p-value is 0.03. Less than 0.05, which is allowing us to reject the null hypothesis. His is the only case where we can do that. Everyone else was above 0.05, so we don't know. Now, I was shocked at this result. Like I said, I was expecting grouse to have a lot more first and second places, but I was not expecting a CPU to have such a high number of last places. The rest And as ever, the rest of the results, I thought there would be more opportunities to reject the null hypothesis based on how the results looked, but they looked worse than they are, and Pitt's the only one that we can reject the null hypothesis on. As always, we have a risk of a type 1 error, so rejecting the null hypothesis when we shouldn't, and there is a 3.3% chance that's what's happened. And of course, as always, the risk of a type 2 error, failing to reject the null hypothesis when we should be. Although again, I did 100 trials, I'm not worried about that aspect, about a type 2 error. Or at least I wasn't. See, the more I thought about it, the more I realized that by using grouse instead of me, I'd introduced an extra variable into the experiment that I shouldn't have. So, in the interests of scientific rigor, I reran the experiment with me, and it left me even more confused, because the results that time looked like this. And when I did those calculations, I discovered that we failed to reject the null hypothesis on all of them. So what that means is that there is insufficient evidence that the data we gathered wasn't purely random for all of my me's, or all the me's on the second run through. Now, I was astonished. I was just very surprised by this entire situation. So I think the question we need to be asking ourselves is, where do these results leave us? And after doing some thinking and going over what we gathered, I think I've got a theory. A game theory. And I do mean a game theory, because that's kind of what this is at this point. See, I was so surprised. That's why this video has taken so long to come out, and why I needed to rerun the experiment, because I wanted to make sure that I didn't come to you with something that was faulty. Something that the more I thought about it, the more I realized that I had introduced that extra variable of grouse versus me. And after running the second experiment, I'm actually even more worried. So stay on. I have a theory about what could be happening. Hear me out. You see, me has beaten highway rollers on beginner difficulty, but not standard difficulty. And from the results, we see that on beginner difficulty, our test was inconclusive. However, my guess is in that case, it is most likely actually randomly distributed. Well, grouse hasn't played highway rollers at all. I merely made the me so that when we're done with Wii Party, we can have a Wii Party U series right away. So here's my theory. Hide and Go Beak behaves differently depending on whether the player me has beaten a main game at the specified difficulty. So for example, if my me hasn't beaten highway rollers at beginner difficulty, then the game will behave in a similar manner to what we saw with grouse on beginner difficulty and my me on standard difficulty. That is, picking a me and then biasing the game either for or against it. And I'm assuming that second option, the for or against, is random. But when my me does beat beginner difficulty on highway rollers, Hide and Go Beak is going to be truly random, or at least as close as a computer can get to truly random. We know that the game does keep track of which difficulties a me beats. That's why expert and master difficulties aren't unlocked from the get-go. So it's possible that it's using that data to determine behavior in RNG minigames such as Hide and Go Beak. However, to prove it, I'm going to need your help. In the past 2 episodes, I've shown my procedure for these experiments as well as laid out the assumptions I've made. But I can only collect so much data. These trials and the data collection takes around 2 hours per run. And I'm quite a busy person. I can't do more than a couple. That's part of the reason why this video took so long to come out. So that's why I'm calling on you, the viewer, to use my procedure, use my assumptions, and repeat what I did. And once you're done that, either join the Discord, there's going to be a link to it in the description, or leave a comment on this video and tell me the following. The difficulty that you tested on, whether the me you played as has beaten a main game on that difficulty. So if you are playing on standard difficulty, tell me whether the Mii that you're playing at has beaten, say, Highway Rollers or what have you on standard difficulty. Number 3, the number of times you and the CPUs got first, second, third, and fourth. That's going, and I need it for all of them, so I need the number of times your player character got first, second, third, and fourth, and the same for all of the 3 of the CPUs. And last but not least, the number of trials you did, so I know roughly, so I can determine what needs to happen with it. Once I've got that, I can do the analysis and I can make a follow-up video going over what we've learned once I've got enough data. I don't know what's going on with this minigame, but one thing is for sure, it's not what it seems to be. And based on what we've learned, I'm inclined to believe that the Mii itself and the CPU Miis don't affect the game's behavior, so I am comfortable calling on the community to repeat the experiment. We need to make sure that the first 2 trials are not a fluke, or to make sure that the 3rd trial we did wasn't a fluke, because maybe it's both, maybe it's neither, I don't know, but I need your help to figure it out. And with that in mind, it's time to end. Thank you all so much for watching, and if you are finding this interesting, please leave a like and please subscribe. There's a lot of questions still left to be answered about Hide and Go Beak, especially in particular regarding its behavior on advanced, expert, and master difficulties. And of course, if we can figure out if the game is adjusting its behavior, depending on whether you've beaten a game in the first place. So, and I intend to get some answers. Now, thank you again for watching, and I'll see you on the next one. Goodbye.